हेलो। गुड आफ्टरनून गाइस। आवाज़ आ रही है मेरी?
यस सर।
सब लोग एक बार एटलीस्ट एक बार अनम्यूट कर लो तो पता चल जाए कि कितने लोग हैं। 17 स्ट्रेंथ है। स्ट्रेंथ को क्या हुआ? ट्यूटोरियल में इंटरेस्टेड नहीं है क्या लोग? यार ट्यूटोरियल ऐसी चीज़ है ना कि थोड़ी सी इंपॉर्टेंट है, क्योंकि जो तुम्हारी जो थ्योरी क्लासेस हैं उसमें जितनी चीज़ें पढ़ाई जाती हैं वो सॉर्ट ऑफ एक फाउंडेशन चीज़ है। मतलब तुम्हें अंडरस्टैंडिंग बढ़ाने के लिए प्रोफेसर उतना टाइम दे भी नहीं सकते। मैं जैसे जितने भी ट्यूटर्स हैं वो तुम्हारे एक्स्ट्रा ट्यूटोरियल भी ले सकते हैं जितना तुम बोलो। तुम कहोगे कि सर ये समझ में नहीं आया, हम 3 या 4 ट्यूटोरियल और ले सकते हैं, कोई मुश्किल नहीं मुझे। और क्वेश्चन पेपर भी जो बनेगा वो ट्यूटोरियल ट्यूटर का मेन कंट्रीब्यूशन रहता है उसमें, कि कितना किसे आसान क्या लगता है उसके हिसाब से चीज़ें बनानी। तो अगर तुम लोग ट्यूट नहीं आओगे तो एक काफ़ी बड़ी चीज़ मिस कर दोगे बेसिकली। राइट। सो आखिरी ट्यूट सबने देखा था, ट्यूट 1? हेलो।
यस सर, देखा था।
So any problems in Tute 1? So if there are any problems in Tute 1, you guys can actually share it me now. No, as discussed earlier, I can take as many as Tute classes as you guys want. I can take 2 or 3 Tutes per week. If you guys are facing problems in solving tutorials, or you are getting stuck in theory or some concept that you want to clear, I'm always up to take more tutorial sessions. Okay. So if everyone is okay with it, with Tute 1, we can just move forward to tutorial 2. Has everybody tried this particular tutorial?
यस सर।
Okay, so any difficulty? Let's say in question 1. So how you guys are planning to, do this
सर,
question 1? Yeah,
हेलो सर।
hello.
Actually, we don't have the answers of this question, so we don't know that my answers are correct or incorrect. So
Answers I
can
can
provide.
answer I can share, right? Answer is not a big deal. The big thing is that once you have solved it, you are satisfied with your solution. Like, if you have solved all of this question, or are you all guys satisfied with how you have performed or how you have solved the question?
According to me, I have solved.
Yes, Panjay? Hmm. Okay, so
According to me, I thought कि मैंने तो सही सॉल्व किया, बट आंसर सही है कि नहीं उसमें थोड़ा डाउट
वो
रहता है।
वो मैं शेयर कर दूंगा. So I cannot share it on the Google Classroom because a lot of you have not still, what can I say, completed or submitted the assignments and tutorial completely, as I was seeing. One of the most important thing here is the grading on the assignments. So when I start grading on the assignment, all of for all of you guys, the grades actually contribute to more than 30% of your total grades, including all of the assignments. Okay, so it's I have it out in 10th question. And okay, the last one. Okay. I will actually discuss this one. So it is very important for you guys to actually submit the assignments. If you do not submit the assignment, it will be a bit of a problem for me, because if I actually have grade 0 to you, uh, a big portion of your grade will be actually lost. So as a fellow student, I do not really want to grade anyone 0. So I request all of you to at least submit all of the assignments completely. I can also not grade any values like as a spam 7 to 10 for all of you. I have to actually check it. and it carries a big portion of your grade. And since half of your semester is online, that's why the portion for your assignments has been boosted up. Because in online mode, if I don't think your midsem would be online. I think you guys will reach before midsem. But if in case it goes online, the weightage for your midsem will actually go down, because the online examination contain lesser weightage, because everyone can actually just copy in online examination. Okay, so I think the Word document is not displaying values correctly. Let me see. Mhm. See if I can make that. Okay, now is it visible for everyone? Hello?
Yes, sir.
So in on the left hand side, I think there was some problem in displaying or rendering the Excel values for all of this. Hence, I also opened a PDF file in the right hand side for your guys' reference. Okay, so first question. Find the R equivalent and I naught in the circuit. So do you guys are facing any problem in this one? No, right? We can actually see this complete circuit is just the sum of series and parallel. If we just compute all of the resistance in series and then just compute all of them in parallel and then again in series, we'll actually get to our answer right here. Can anybody who has actually solved it unmute themselves and tell me a method on how to actually do it?
Yes.
Okay, yeah, sure, Ranjan.
Then सबसे पहले ये 80 ओम एंड 20 ओम सबसे पहले पैरेलल में था, तो उसको सॉल्व करके 16 ओम
Okay, good one, Paranjay. He was actually trying to explain that we have just two methodologies. Okay, for if you guys actually remember, there are actually two ways how we check if two particular elements are series or in parallel. So if we start, if we have a particular element like this, let's say it's a resistor, and another element like this, it's also a resistor, and if both of the terminals are connected like this, with no element in between this connection. Okay. So this particular connection is called a parallel connection. And if we actually look at the connections right here, we can actually see this one right here and this one are connected in parallel, right? These two elements, the 20 ohm and the 80 ohm resistance, right? And these two particular elements, this one and this one, right? These two are also connected in parallel. And the elements which are connected in series are if in this particular configuration,
रिजल्टेंट ऑफ those two
just a second.
80 and 20 and 12 and 6.
Yeah, so we just take the parallel combination of 80, 20 and 12 and 6. So what would the answer, Panji?
80 and 20 gives 16 ohm and 12 and 6 gives 4 ohm.
Yeah, 16 and 4 ohms. And then what we will do, we also
Then those
then
16 ohm and 4 ohm will be in series.
yes, 16 and 4 ohm would be in series, and
We will get 16 plus 4 20 ohm, then 20 ohm, 60 ohm and 15 ohm will be in parallel.
yeah. Okay. So final resistance would be what actually? 60, 12, 16. mm, It would be 10 ohms, right?
10 ohm.
Yes, sir.
Yeah,
10 ohm.
10 ohms. So the actual final resistance here that we'll get is actually 10 ohms. Does anyone have a problem with how I'm just solving the problems? Because I think this is just too basic. So if I just actually draw everything, it would be too slow for all of you guys. Hence, I'm just hovering over the particular problem statement. So if anyone actually has a problem with this, they can actually just unmute themselves and just say, I didn't understand how this particular problem is solved. I can actually share a step-by-step solution. But for now, we can actually see the R equivalent, which is just suggested as the equivalent resistance across this voltage source, would be around 10 ohms. And once we actually get this particular equivalent resistance, we can actually use this particular bat voltage source, 35 volts, to actually calculate how much current will be passing. 3.5 ohms would be the current, right?
Yes, sir.
Okay.
Yes, sir.
Cool, because if the R equivalent is 10 ohms, we have 35-volt voltage source. So current would be V by R, right? Now the second question is the 60-watt light bulb in figure 2.2 is rated 120 volts. Calculate the value of Vs to make the light bulb operate at its rated conditions. Okay, so did anybody attempt this question?
Yes, sir.
So how did you guys approach it? First of all, do everybody understand like if particular what is the rating what wattage of a particular bulb, rated wattage, rated current, and rated voltage?
Yes.
It's actually pretty simple, right? You guys have probably studied about it in your J examinations. If a particular appliance is rated at a particular wattage, it is generally comes with another rating called as its voltage rating. Right. It doesn't, most of the appliances do not come with a current rating because the uh, supply that we actually get is in terms of voltage, not actually current. So if we have a particular bulb and it is rated 60 watts, and we know it is rated at 120 volts, right? So what can we know about it? So we have its power, right? And power is actually, we know what it can be written as V square by R, right? Or it can also be written as I square R, right? And since it can be written in both of these terms, if we know the power, we know the voltage, we can actually get its resistance, right? And what would this resistance be? Is it's called the it's called the production impedance or the manufacture impedance of a particular appliance. Like we know the most of the bulbs which were used in the ancient times, which were not fluorescent or LEDs, they were actually tungsten-based bulbs, right? We had a tungsten wire in the middle, and when we actually pass a particular current through that wire, we actually had a glow on the bulb due to the collision of electron and protection of heat, and so the light. But nowadays, fluorescent bulbs have come and PN junction bulbs are there like LEDs. So things have things have changed a bit because now we do not have a linear resistance factor. Do you guys know about ohmic and non-ohmic devices?
Yes, sir.
Yeah, right. So ohmic non-ohmic devices refer to the devices which follow the Ohm's law or do not follow the Ohm's law. Uh, and the fluorescent light bulb, which actually, do you guys know about fluorescent light bulbs, CFLs? Does anybody know about it? How fluorescent light bulb work or CFLs work? Okay, so you guys don't have to actually worry about it. You guys can actually either answer yes or no, or you can just give a wrong answer. I wouldn't really mind. Okay. So fluorescent light bulb actually works by a very simple principle. Roughly, for understanding, you can just think it as a particular tube having electrode on both ends, and it is filled with some sort of gas, pressurized gas, and it is inert in nature mostly. It could be helium, it could be neon, or it could be any other bulb. Okay, so we actually have a fluorescent property in inert gases. Right? So when there is an electricity passing at higher voltages, mm, no, plasma is actually a different state altogether, right? We can actually convert inert gases to a plasma state, but we do not actually need plasma. What we need is actually a conduction, a voltage arc, basically. Because do you guys know about voltage arc? Like we have a particular dielectric, in this case, a helium, and we when we keep increasing the voltage between these two ends, what happens is some at particular point there is a dielectric breakdown of the particular of the whole medium, and when the dielectric breakdown occurs, the electron starts to just jump from one particular neon kernel to another neon kernel, or helium kernel to another helium kernel, and the energy released when it jumps is supplied by you, and when it just actually recombines with another kernel, it emits electromagnetic radiation, and that electromagnetic radiation would just obviously depend on the gas itself, on how much is its particular release energy, absorption energy of that particular orbital in which the electron is going. So it reaches a particular wavelength, and that wavelength becomes our visible light. That's how roughly the CFL works. And nowadays there is something called LEDs. LEDs basically work on PN junction, and both of these, as you guys can guess, are non-ohmic in nature, right? Both of them are non-ohmic in nature, and hence, since they are non-ohmic, their manufacture resistance is not constant. That depends on your operating temperatures. Hence, what we do is when we are actually given a particular statement like this, we actually consider them as ohmic devices, right? So when we consider them as ohmic devices, we know that R that we have obtained here is actually constant, right? This would not change. Whatever R value we are actually getting here would just remain constant. And from that R value, if you put it here, we can actually also get the current flowing through the bulb. Anyways, what we actually want is actually to have 120, since we have a 120 volt operating voltage of this particular bulb, we can actually also calculate its resistance and its current, right? And one of the approaches that we can follow is actually apply some sort of a KCL equation at this node, particular node here, this particular node. And what we try to do is actually try to make the bulb get this amount of current that we have calculated. Or what we can do is ensure that the voltage across these and this terminal is what we have actually rated beforehand, right? So what actually algorithm are you guys, or what way, not algorithm, what way are you guys following? How did you actually approach this question for those who have actually solved it?
Like first of all, I find it the current through the bulb.
Current through the bulb, okay, nice.
Th- Then we need the net current coming from VS. तो रेजिस्टेंस के इनवर्सली प्रोपोर्शनल में करंट
Okay,
पास होता है, तो उससे मैंने नेट करंट निकाल लिया.
okay,
देन सर एक बैटरी एक रेजिस्टेंस का सर्किट बना के VS फाइंड आउट कर लिया.
okay, cool. So that is actually one of the way in which how you can do this. I think if I have to, exact check the numerical answer for this question, I can actually do it. I have solved these. Mm. Yeah, so what was the answer you were getting?
200.
200 watt.
200 volt. Yeah, correct. 200 volt is actually a correct answer. Cool. I have actually done it by the voltage method, right? So my method was to actually find out the voltage drop across this 40 ohm resistance, such that the voltage in this particular loop, Vs, 40 ohm bulb, and this particular mesh is such that the voltage across this bulb would be 120. So the voltage drop across this 40 ohm resistance was coming out to be, I think, somewhat 80 volts, I guess. Yeah. So 80 plus 120 comes out to be 200 volt for this particular voltage source. Okay, so that's a good way to solve it. Okay, do anybody have a problem with this on how this particular problem is being solved? For all of those who actually want detailed solutions or queries, they can actually note down my number, because I'm not going to actually share the solutions on the Google Classroom itself, because a lot of people have not actually submitted the solution, and if I share it, they will just copy it. So I do not want that. So for those who have actually done it and want to just test or verify the solution, they can actually uh, message me on my mail 22ec3025 @rjpt.ac.in, or they can actually message me on WhatsApp. Okay. I will actually tell my number right now. It is 7398 569798 for everyone who actually wants to verify their solutions. And for those who actually have a doubt right now, they can always ask. Don't hesitate to ask anytime. Cool. So now next question is, three light bulbs are connected to a series 120 volt source as shown in figure 2.3. Find the current I through each of the bulbs. Each bulb is rated at 120 volts. How much power is each bulb absorbing? Do they generate much light? If three bulbs in 2.3 are connected in parallel at the 120 volt source, calculate the current through each bulb. This question is actually pretty simple. I've actually already told you how to actually calculate the manufacturer resistance or manufacturer impedance of a particular light bulb, right? Do you guys remember? Hello?
Yes, sir.
Yes, sir.
Yeah. Yeah, okay. I will do. Paranjit. So, okay, we all actually remember power is nothing but P square by R. If we actually know the power and we actually know the current or the voltage, we can calculate the manufacturer resistance. And once you have the manufacturer resistance, we can actually see here each bulb is rated 120 volts. We know the power rating, we know the voltage rating, and hence we can actually find out the manufacturer impedance for all of these bulbs. And if we once we find the manufacturer impedance for all of these bulbs, this will actually simplify to a simple battery and a resistive circuit like this. Right? All of you agree?
Yes.
Okay. So you can actually simplify it to this, and you will find the current. And then once you find the current values here and the total power loss, and then you can actually try to connect them in parallel, and then try to find the total power loss. And actually, one thing to keep in mind, the power loss here is actually also due to heat, not only by light, right? But what we do is we do not actually consider the heat part. Okay, we assume that all of the I square R power is just becoming light itself. So if lesser power is being consumed, it will probably produce lesser light. This is one assumption you have to keep in your mind before solving this question. Okay, is everybody with me? There's some sort of problem. Cool. So how much Vijay sir has taught you guys till now? Hello? You guys actually studying EC, right? FE, fundamental electric. So you guys actually have probably covered some sort of syllabus till now. What is it?
Network theorems.
Network theorems. Okay. And bit more specific.
Thevenin Norton.
Thevenin Norton. Okay. So
Superposition theorem.
superposition theorem. Okay. Cool. So are you guys all understanding all of that? Because it's also a bit basic. You guys have probably studied in your JEE terms, but are you studying in context of pure electronics itself? because actually I wanted to just share some of the simulation tool with you right now. Because we are at third year working as we are working with the industry, we have a lot of simulation tool that we use. And to actually get used to those simulation tools, it takes a significant amount of time. And I wanted to just share a lot of material and notes and simulation tool with you guys, which you can actually use in your free time to actually get intuition of building circuits, understanding circuits, synthesizing circuits. But I'm just afraid it would be a bit too much or it would be a bit hectic for you guys, apart from your assignments and tutorials. Would that be the case? If that's not the case, I will probably share it with you. Because if any one of you actually just starts commenting on the Google Classroom that all of this is just too much and too hectic, Vijay sir would probably tell me to, not share any further. Yeah. Okay, so Shashank agrees with me. So if rest of you actually agree with me, I would actually try to share it. Okay, cool. Now, what you want to know in this particular question? I'm struggling in maths, physics and maths, electronics is okay till now. Uh, so Akshat, physics and maths would be the things you should not be struggling with at this particular moment, because the physics and maths in first semester would be, I think you would have classical physics course and also RAC, real analysis and calculus, probably. And yeah, and that's something that you have to actually spend time on, because after coming to second year in electronics, most of the electronics is just mathematics and physics, right? um, I think this all of the circuits and equation you're just circuits you're building would just all be reduced to equations mostly. Equation, frequency response, time response, and other domain analysis, Fourier analysis and stuff. It should be probably most of it would be maths. So I think it would be better for you to actually focus on maths and physics and try to study it, because it would be mostly on from your derived from your J syllabus, and some of it, yeah, it is difficult, or some of it is something that you have not studied, but you should try at least. Try your best. You should not ignore maths and physics because electronics is going good now. Because this electronics is very fundamental, right? Yeah. So this electronics is very fundamental, and it would not be a good idea for you to just not pay attention to physics and maths because electronics is okay. So you should try to pay attention equally to all of these three things. Cool. So now we have a question. Find ZAB in four-way power divider circuit given as follows, and assume each element is 1 ohm. So this looks relatively simple to me. Is it for everyone?
It's Stone Bridge.
Yeah. Okay. Wheatstone bridge, and it's a balanced Wheatstone bridge, right?
Yes, sir.
So since it's a balanced Wheatstone bridge, we can always ignore the 1 ohm resistance in the center. Can we?
Yes, sir.
Yes, sir.
Yeah. Actually, guys, when you will actually study power transmissions and power electronics, what would happen is you cannot actually just ignore this 1 ohm resistance in the center, because it has a coupled reactive effect on the particular circuit. I'll just ignore all of that. But I was saying in this particular example, yes, you can actually ignore this 1 ohm circuit, 1 ohm resistance in the middle, and you can just calculate the series and parallel equivalent impedance. Right. Everybody know the difference between impedance and resistance.
Yes, sir.
So what is it, Sambhavi? So what is the difference?
The resistance is the obstruction offered by any element, current circuit element, denoted by R. and impedance is the total or equivalent resistance or obstruction that is offered by capacitors, resistors, or voltmeters together.
Yeah, okay. So it is a good definition. But resistance is something which is applicable to passive elements only, right? So if it's a passive element like a resistor here, it can offer a resistance. But if it is not a passive element, it is an active element, it will offer something called a reactance, right? Everybody studied about reactances. They probably have not studied about reactance, guys. Hello? Okay, so what happens is there are a lot of different types of elements which are offering a sort of resistance or sort of stopping effect to our to changes in current or voltages, right? So some of them are passive in nature, like our resistor, and some of them are active, like our operational amplifier or a particular capacitor or an inductor. So we have reactances for all of those particular elements. And the total obstruction that they are actually offering is what we know as the impedance that we calculate, like she rightly pointed out. It is calculated by all of the particular elements, that's resistor, capacitor, and inductor. But as we all know that the capacitor or the inductor are, inherently incapable of providing, ohmic resistance, right? Because they are, almost perfect conductors. Because they're just completely conductors. Like inductor is just a coiled conductor. It technically cannot just stop the flow of current or the flow of electrons, or just dissipate the flow of current or flow of electron. It can only just store the energy passing through it for a short amount of time, and can also cause phase delay in alternating circuits. Anyways, so we are asked to find the impedance here across A and B, and the impedance would be equal to the resistance which we have calculated. Okay. Again, I can just mark it here. Uh, this, this, and then the equivalent resistance comes in this. All of these three can be neglected. Yeah, you can just actually neglect all of these three. Cool. So now the next question is, using nodal analysis, determine V naught. Okay, so who has actually attempted this one?
I've done it, sir.
Good. So the what would be your general approach? You have used KVL or you can use KCL here. What have you used?
Simply nodal at V1 and V2.
Uh,
The
I don't think you are audible. Can you just speak a bit louder?
nodal at the point between 20 ohm and 10 ohm,
Yeah. So you have
and then
okay, right. So you have used KCL here. Okay.
yes, yes, sir.
Okay. So he's also actually writing the answer in the comment section. Good, guys. So we can use if you're trying to use the KCL or the KVL or the voltage law, we have three meshes here. The 40 volt, 20 ohm, and 20 ohm mesh, and then again 20 ohm, 10 ohm, and then 4I naught is it? I think so. Yeah, 4IX. Yeah, 4IX it is. In this, and then we again have another mesh. If we use a mesh analysis, the thing is we have a current source in between the meshes, and what that current source will make the both of the meshes as a super mesh. You guys remember super mesh? Hello.
Yes, sir.
Okay, so if all of you guys actually remember Supermesh, it's very simple. We actually what we do is just keep both of the currents independent, and we remove the current source temporarily, and then we actually make another equation with the current source as the current source is the particular is the only current which is dividing into the current of the meshes on the right and left. So we make one equation from there and one equation using the independent current sources, let's say I1 and I2 in both of these meshes. So yeah, that's how we can actually do it. That will make how much? One, two, three, four. Yeah, four equation and one dependent equation, and we can actually find out all of these variables, whatever we are being asked. And another way is like how Pranjit did it. We can actually do a nodal analysis, and we can make a node between the 20 and 10 ohm resistance, and we can apply the Kirchhoff's current law, right? And try to find out all of the parameters right there. Cool.
Yes.
Yeah.
Can you please reconfirm the answer of this question?
Okay, just a second. I have actually solved it. I think the answer I got was 60 volts.
Yes.
Yes, sir.
Okay,
60.
cool. So the answer you guys will get is 60 volts for this particular question. So anywhere you guys are thinking that I'm going a bit too fast, or I know I'm not just solving everything, you guys can always stop me and ask me to solve all of the questions. I will try to do that. I will actually do that. I'm actually hovering through all of the answer because I think you guys are pretty much familiar with all of these terms, because my plan for a 2 or 3 tutor session is when you guys will start with analog circuits or analog electronics in this fundamental of electronics engineering course. You'll start with uh, two particular topics. One of this is communication, analog electronics, and digital electronics. And all of those three electronics part are actually very interesting for your future references, because fundamental electronics engineering courses because the whole 2 years of electronics combined into one particular course. So you will actually keep studying all of the courses that were the part of the fundamental electronics engineering course, but in more detail in future classes. So what I will try to do is explain those in great detail, so you guys would never face difficulty in those subjects in future. Now it's very simple, and I don't think there is something to actually have a doubt on. Cool. So the other thing is use the nodal analysis to determine the voltage in figure 2.6. 2.6 is here. Anybody has a problem in this question?
Yes, sir. Sir, I have solved it, sir. Can you please tell the answer?
Okay. So the question is relatively simple. There are no dependent sources. We just have to apply a particular any type of analysis that you want, and we will get the answer. Anybody having difficulty in this particular question?
Sir, just can you verify the answer, please?
Yeah, yeah. Wait, just a so yeah, the nodal voltages that I got was 25.52, 22.05,
Okay.
14.842, and 15.05.
Okay. Okay, okay, okay.
Yes, sir.
Thank you.
So everybody got these voltages, right? And across all.
Actually, sir,
Yes.
sir, in examination, do we have to specify the exact, or can we just round off?
Examination,
Or
the good rule of thumb is to actually use two significant figures. Right? Try to use two significant figures in all of the examination you guys face. Don't round off unless it's asked. If nothing is said, just use two significant figures.
like just 25.5
Yeah,
or
25,
22 only?
2.
Okay, okay.
Okay. Okay, so for the circuit shown in figure 2.7, find the voltage V1, V2, and V3 using nodal analysis. It's a very similar circuit as above. Guys facing any problem in this one?
Yes, sir. So can you please tell the answer of this one also?
Okay. So the question I saw.
V1 minus 3.
Yeah, V1 is actually minus 3 volt, V2 is 4.5 volt, and V3 is minus 15.
Minus 15. Okay, sir.
Yeah. So only one guy is actually just telling all the one or two people are telling all the answers. Makes me think the rest of you were not able to solve these questions. Is it true? Or you guys have not had the opportunity to solve this question? You guys weren't free that much. That would be okay if you guys weren't free. But if you guys were not able to solve this problem and I'm just hovering over it, that would be a problem for me. You can solve the 10th one. Okay, yeah. Actually,
Sir,
yeah.
sir, if you want to write the nodal at V3, what will be the equation of there?
Nodal at V3. So
Yes, sir.
what's depends on what is your reference voltage. Okay.
Uh,
So
I consider the lower voltage as
yeah,
0.
this one is what you considered at 0.
Yes, sir.
Okay. So if you have considered this one as 0, then you have a particular voltage source right here, right? On the top of this portion.
Yes, sir.
Yeah. So you have one voltage source right here and another node here. So when we have a voltage source between two nodes, what is it called?
Super note.
Yeah, supernode. Right. So the way I have done it is done a supernode analysis. Just let's see what's the time right now. Yeah, it's 2:46, guys. I would have to just wind it up fast. Uh, so in short, what I've done is actually Akshit, who was asking the question?
Yes, sir. Fine.
Yes, sir. Me also.
Who was uh, Paranjay or Akshit? Akshit, okay. So both of you guys can actually DM me for the detailed solution. What I have done is actually used a KCL analysis on V1, V2, and V3. But also one supernode equation is made between V1 and V3. Okay.
Okay, sir.
Okay. So you have to make a supernode equation. What will that do is actually prevent the problem of finding out the current between the 12 volt source. Okay. So we do not actually need to find the current in the 12 volt source. We will just assume that this V1, 12 volt, and V3 is whole one unit as a one big super node. And we'll try
It
to find,
can be
yeah,
V1 plus V3 equal to 12 volt.
yeah. Then we also have one particular equation as V1 minus V3 is 12 volts, right? So apart from that equation, we also have this V1, 12 volt, and V3 is one particular whole super node. And we know what are the different currents flowing into this full particular node, right? We have to think in that way, as this is one full body and the current is flowing through this one particular full unit, as this all of this is just one big node. Okay. So 8, 9, and 10 are remaining. I will actually try to, write a step-by-step solution. Okay. So what's the doubt in question number 10 actually?
So like what do we have to do by the word inspection? Like just can't I use KCL given and just solve it like that? Or I did not understand the word inspection here.
Write the nodal voltage by inspection. So in figure 2.10 here, right? This one.
Yes.
So what's the problem with the word inspection? What do you understand by the word inspection?
Sir, I guess we have just to write the equation and
Yeah, so the thing is that what you have to do is in this particular question is not just do it linearly. Like what we're doing in previous analysis is we're just using a particular mesh or particular node, and we're just writing the equation for that node and the other nodes in the system, or for that mesh, other mesh in the system, and using a system of linear equation to find out all the variables. What will we do here is just simplify it in terms of either resistances or the conductances. because all of these sources here are current sources. We can see, since all of these are current sources and all of these elements are resistive elements, we can actually just make a conductance equation for the elements right here, or the meshes right here, or the nodes right here. Do you guys understand or follow me?
Sir, how to make a conductance equation?
Yeah, I will share it because we are, I think, lagging time. 250 is already there. I've also
Okay,
take attendance. After taking the attendance, if I have time, I will just write the conductance equation, or I will share it to you on my email or the Google Classroom. So just a second, I will try to take.
नहीं का solution कहाँ मिलेगा फिर?
हेलो, ट्यूट का सॉल्यूशन यार,
Q21 का
का सॉल्यूशन तब मिलेगा जब सब लोगों ने ट्यूट जमा कर दिया होगा। अभी ट्यूट का सॉल्यूशन नहीं मिल सकता क्योंकि अभी सबने जमा नहीं किया है। ठीक है, किसी को किसी में प्रॉब्लम है वो मुझे डायरेक्टली मेल कर सकता है, मैं क्वेश्चन बाय क्वेश्चन सॉल्व करके दे दूंगा। ओके, मैंने मेल भी शेयर कर रखा है, नंबर भी शेयर कर रखा है, किसी पे भी एक बार मैसेज कर दूंगा। डायरेक्ट दे सकता हूँ गूगल क्लासरूम पे, तभी देंगे सॉल्यूशन जब सबने सबमिट कर दिया होगा। कूल, सो प्लीज गाइस अटेंड टू योर
डेडलाइन के पास है। तो पहले वाले के पास हो गए ना।
एक सेकंड, क्या कह रहे हो?
Q21 का डेडलाइन तो पास हो गया ना सर।
पर सबने जमा किया नहीं था, तो इसलिए मैंने शेयर किया नहीं, पर चलो ठीक है, कर देंगे आज ट्यूट 1 का सॉल्यूशन शेयर कर देंगे। ठीक है, ईमेल सबको मिल गया रुपये? Cool. So attend to your roll calls, guys. EC1 present. Okay. EC2,
Present, sir.
EC3,
Present, sir.
EC4, EC5. Yeah, 4, EC4.
Present sir.
EC5, Akhilesh.
Present, sir. Present, sir.
EC6,
present sir.
EC7,
Present sir.
EC8, EC8, guys, absent. EC9,
Present, sir.
EC10, it's absent. EC11, EC12,
Present sir.
EC13, EC14, EC15,
Present, sir.
EC16,
Present, sir.
EC17, 18,
Present, sir.
19,
Present, sir.
20,
Present sir.
21, 21, okay, 22, 23,
Present, sir.
24, 25, 26, 27, 28, 29,
Present, sir. Present, sir.
28 present,
29.
28
Sir,
present, okay, 28,
22 present. Connection restored.
okay, 22 also present, 30, 29%, okay, okay, 29, 30, 31,
Present sir.
32,
Present, sir.
33,
Present, sir.
34, 35, 36, 37, 38, 39, 40, 41,
Present, sir.
42,
Present, sir.
43, 44, 45,
Present, sir.
46, 47,
Present, sir.
48.
Present, sir.
Okay. Thank you guys for joining. And I will actually share the solution to question number 10 on the Google Classroom itself. And you can guys also mail or message me for any other queries. Thank you, everyone.
Thank you, sir.
Good day, sir.